Okay, this video should finish up the physical and chemical changes lab for those of you who zoomed in to the lab. I'm going to be doing steps 9, 10, and 11. It's a little bit involved, but I'm going to do my best. Okay, so for each one, you're going to read what happens, make your prediction, then observations, then conclusion about whether it's a physical or chemical change. So step 9 says, place 1 spatula scoop of copper 2 sulfate pentahydrate powder into a test tube. Attach the test tube to a ring stand with the test tube clamp. Heat gently over a burner flame for 5 minutes or until you see a color change. Allow the sample to cool and then add a few drops of water. So if you haven't yet, pause the video and make a prediction about whether you think this would be a physical or a chemical change. There are some hints, but this is one that is maybe a little tricky. Okay, instead of doing this whole step, I'm going to show you a before and after. Okay, so this is a scoop of copper 2 sulfate pentahydrate compound beforehand. This is one that a group hadn't gotten a chance to get to yet. It's a light blue powder. And when you heat it gently, you heat it with the flame and an air space, and then this. And what you start to see is this. Now I hope you can tell. I like this one because for contrast, you can see that it's still a little blue in the middle, like there, but that it's more white on the outside where it would have been warmer. So it's getting white on the outside where the flame would have been in contact with it. So that's some observations that as it was heated, oh, that's a good angle there. As it was heated, they started to go from blue to white. And now we're going to add a few drops of water. Okay. And that blue color comes right back. It didn't get all the way around to all the sides of it. That blue color comes right back. So there's your observations for step 9, and I think there are a lot of hints about whether it's a physical or a chemical change. The blue color came back easily. Big hint. Okay. Step 10, make a prediction after you hear what is happening. Using a lab balance and weighing paper, measure out the following samples: 0.5 grams of iron filings and 0.5 grams of powdered sulfur. Mix the two, there's a hint, in the test tube and run the magnet along the bottom and sides of the tube. So, make a prediction about whether this is a physical or chemical change. Now, because you are not here, I want to show you the weighing out part of it, actually. I have these already. Here's my 1/2 gram of sulfur. It's yellow powder. Okay. If you find sulfur in the ground, it looks like a yellow rock and you crush it up. Okay. And then here's my 1/2 gram of iron filings. Okay. But this is a skill. This is something we worked on. If you know how much of something you want to weigh out, if you know you want exactly 1/2 gram of something, there's a very specific procedure for doing that. And the students who did this in person practiced that procedure. So I want to show you, the general idea. It's not like weighing an object. It's not like placing an object on and then finding the mass. It's sort of the opposite. If you know the mass you want, you're going to make the scale read that first and then add. So, but there's also the weighing paper. So the weighing paper weighs something. So I put it on here and I figure out what the weighing paper weighs. It's sort of like zeroing the balance. Like if this were an electronic balance, I'd put the paper on and then I just hit 0 and then I wouldn't even have to worry about it. The weighing paper weighs generally 0.9 grams. Okay, it weighs 0.9 grams. If I want 1/2 gram of this, then when I'm done with this whole process, this is going to read 1.4 grams. I'm going to do that now because if I start adding this, how in the world will I know when I get to 1.4 grams? I won't know unless the scale tells me. So I scoot it up to 1.4 grams. It's out of balance, but I know that it's out of balance by exactly half a gram. And then I'm going to add the substance slowly and carefully until it balances out. There's something else to know here, which is that if you go too far, you cannot return this into the original container. That's a no-no. That's a safety rule. So you also have to have like a waste beaker or a waste piece of paper that if you go too far, you could put the excess on that waste paper. So just an example. And I'm watching, as I'm adding this, I'm watching the balance like slowly come up. Nice. So now I know I have half a gram of iron filings. Okay, mix them. Okay. This is also something to know how to do physically. I folded this weighing paper on the diagonal so it would act like this little cup and sort of hold my substance, but it also helps me turn the paper into a funnel, into its own little funnel, so I can get my substance. I go tap, 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 and I can get my substance into the test tube easily. Weighing paper is one-time use. This gets thrown out now. Okay, so there's half a gram of iron. Here's my half a gram of sulfur. There it is. Okay. Come on. There we go. Throw that out. Okay, so observations. You can clearly still see both of them. You can see the dark iron, you can see the yellow sulfur. It's washing out a little bit, it's looking white to you guys. And then here's the magnet. Looks pretty cool, actually. So these are all observations for step 10. And this is all that's happening in step 10. So I bet you can guess whether this is a physical or a chemical change and write your conclusion. Okay, in a sec we're going to do step 11. Okay. So for 11, make a prediction based on this. Attach the test tube to a ring stand with a test tube clamp. I'm ready for that. Heat the iron and sulfur mixture in a burner flame for several minutes until the mixture glows. This is going to smell. You guys are lucky you don't have to smell this. Allow the sample to cool and examine it by probing it with a microspatula as well as retesting with the magnet. I'm going to get this started and then I might pause the video. We'll see. We'll see how much of this, how long it takes. Okay, so this guy's going up there. In lab, we've talked a lot about test tube clamp placement. Anytime, no matter how I'm heating, I want the test tube to be sitting low in the test tube clamp so that this rubber clamp is not what I'm heating. I want to heat the test tube, not the clamp. This rubber can melt, it can catch on fire, okay, and you don't want to smell it. We want to be seeing what's happening with the test tube. And then the height of this is really going to depend on the height of my flame. So I'm going to keep this off to the side. I'm going to light the Bunsen burner. I'm going to see the height of the flame, and then I'm going to adjust this. If I were heating gently, I would adjust it high so that it's flame, airspace, test tube. But this one is heating in a burner flame. This is going to be pretty dramatic. This is going to be like right in it. And these test tubes should be able to stand up to that flame. but of course we're wearing our safety gear too. Okay, my flame's about here. I'm going to lower this. I may end up needing to turn the fume hood on just for ventilation if this gets smelly, which would be loud, so hopefully we don't have to do that. Ooh, it's already bubbling and going a little crazy. Look at that, looks like lava. Now, the glowing part comes from this yellow steam that you see above. It's not like a very vigorous glow, but maybe you sort of see what we mean by glowing. Ooh, there you go. You're starting to get that glow. Okay, I'm going to pause this and let this reaction finish and maybe cool down to finish the observations. Okay, I haven't actually let it cool down all the way, but enough to make observations. It is now this like dark black solid mass, and you hit it with a micro spatula, and ooh, mine, now I got a little bit of lava on here because I didn't actually let it cool down all the way. It should be solid. It should be that you hit it with the micro spatula and it's completely solid. It looks like one thing, and you probe it with the magnet and you can no longer move anything with the magnet. So those are all your observations for step 11. I think the conclusion for this step is pretty obvious, and do remember to make it absolutely clear for each step what was your prediction in terms of the type of change, physical or chemical, what were your observations, be real descriptive there, and then your conclusion. Your conclusion should really say why you came to that conclusion. Like, this is a chemical change because a new substance was formed, or because we saw something completely disappear, or you get it. Okay? Have a great day.